Hello everyone, in this video we're going to talk about radicals. Now what is a radical? It looks something like this. This is called radicand. This is called index. This is called square root sign or root sign or radical sign. So what a radical, and this whole thing is a radical. So what a radical, the purpose of a radical is we want to say we square a number, but we want to get back to the a without squaring. So we want to inverse, and radicals represent a way to do that. So for example, if a was 10, you wanted to get back to the 10 here before doing the squaring, then you would take the square root of 10 raised to the second power and get 10. Now the reason this is like that is because this is asking like what number raised to second power gives the stuff inside here under the sign, and we know that x must be 10, so the answer is 10. So notice that by taking the square root, we got back the number that was before squaring it. Like this is 100, but if you take the square root, you get 10, because 10 raised to the second power is 100. So that's the idea. Now when you have 2 as the index, then that's taking the square root, but you can also take like cube root or nth root if the n is different than 2. So it could be basically a whole number equal to, greater than or equal to 2. If it's 2, then we don't have to write the 2, we can omit it, and it's implied that the 2 is there. Now one thing to notice is that when you take the square root of 10 raised to the second power, you don't get stuff like plus or minus 10, but it's actually exactly 10. And maybe I'll show you why that is here. So when you square a number, what happens? Let's say x is 10 and you plus 10 and you square it. What you get is 100, right? What if x was negative 10? You also get 100. So notice what happened. You lost the sort of sign information because the answers are same here. So whether x was positive or negative didn't matter. So you can interpret that as squaring a number loses the sign information. So when you square a number and then take the square root immediately, what you get isn't just x, but it's absolute value of x. Now what the absolute value of x means is if it's a negative number, turn it into a positive number, If it's a positive number, then don't do anything. Now, the value for x, actually, like when you look at this expression or equation, it can be kind of hard to exactly get a sense of what it means. So x can be any number on a number line, say real number line, and so x can be less than 0, or it can be greater than or equal to 0. So those are all the possibilities. So let's look at the case where x is 0 or greater than 0. So we're gonna use 10 again, and basically this is gonna be like this, and you get 10 back. So what if x was less than 0? So negative 10. Notice what happens here is, like I showed here, when you square a negative number, it's gonna lose the sign information, or it's gonna turn the negative, even though it was negative, it's gonna be positive 100, and you get 10. So this was like, it was case 1, this represents case 1, this represents case 2. You get the same result, answer, whether you used positive number or negative number. So we can like represent that as like this. Square number and then take the root is equal to x if x is equal to 0 or greater than 0, and equals not just x but negative x if x is less than 0. Because look here, like if you have negative 10 as x, you know, look what happened before. So x is negative 10. What is this when you evaluate it? You get not negative 10, which would be x, but you actually get plus 10. So that means you put a negative sign. So this was like negative x, right? So you can either say like this, or you can say it more conveniently as this one equation. Because when x is greater than or equal to 0, it's just gonna, you don't have to do anything to the sign. You just accept the answer. But if it's less than 0, you're gonna have to flip the sign, which means, and that's what the absolute value signs do, is if you have like negative 100, if you absolute value it, you get 100. So these bars are taking care of the case really when the x is negative. So the second case, okay, so instead of writing these two equations, which are different, see the right hand side is different, we can simply write one equation. So that's how you can interpret that or see what that means. So we just looked at primarily the case where n was 2, so we're taking the square root, but we can also take the nth root, and let me just explain what that means. Is so when you have the 2 here, then it meant what is the number that when taken to the second power, so second power results in the radicand a. So we have 2 x's here and a. Now let's look at when n is 3. So if n is 3, then it's like this. Now we have 3 x's when all multiplied together results in a. Right? So that's the difference, what the index does. And to get an easy answer to this, we can use 10 raised to the third power. So we can easily find this out because this is asking, so the stuff inside here is actually has 3 zeros, is 1,000. So what number raised to the third power results in this, which is this? So we can see that it's 10 just from looking at the visual. If we put 10 here, then it becomes equal. So the answer would be 10 on that basis. So there's some pattern that you can notice. When this is equal to this number, then you get exactly this thing. Okay, but like in general, it's asking the question, what number raised to the third power now results in the stuff inside, the radicand? And we can work out that is 10 because 10 times 10 times 10 results in 1,000. Okay, so this is just going to be an introductory video about the radicals, and I think that's all I'll cover for this video, but I'll see you in the next video for more.